What's up, 8th grade? This video is to help you with homework assignments 8-1K and 8-1G. I'm going to do 3 problems to start with. All right, number 1, it says, what rule describes the linear function for the graph? Okay, so remember from class that a function rule, when it says rule here, it just means the equation, okay? So this is just some new vocabulary that we learned in class. The rule means equation, and we write equations in the form y equals mx plus b. So let's go ahead, take a look at our graph here, and let's figure out what the equation or function rule, those are synonyms, is going to be. All right, first thing I look for is my y-intercept. Remember, if we're going to write an equation, we need 2 things. We need to know, hey, what is our slope and what is our y-intercept? So I look at this graph right here. There's my y-axis. I go down. My y-intercept is at -5. Okay, my y-intercept is -5. Then I start at this point, and I'm going to move up the blue line until I get to a point where it goes right in between the crosshairs. And for me, that is right there, very close. All right, how do I get from this one to that one? I have to go up 1 unit. And I have to go to the right 1 unit. I know that's kind of small, but that's because it's only up 1 over 1. So my slope is up 1 unit to the right 1 unit. So let's write the equation for this line. The equation for this, or the function rule, again, we're introducing some new vocabulary here. The rule for this is y is equal to, well, this is just equal to 1. Right? 1x minus 5. Now, if you look at my 4 choices over here, you're not going to see this because they simplified the 1. Remember, 1 times anything is just that thing. Right? 1 times 5 is just 5. 1 times 10 is just 10. 1 times x is just x. So the way that they're going to write this, I'll say or. Right? You could write it this way, but the way the computer is going to write this is y is equal to x minus 5. And I go and look at my choices. There it is. So unfortunately, I have to close this little window here. And it says, choose the correct answer below. I am looking for y equals x minus 5. There it is. Got it. Okay, so when it's asking you to write the rule for the different graphs that it gives you, that's review. Okay, it's review from last unit. It gets a little more wrinkly in this unit. They're going to throw a few more wrinkles at you, and they're going to use this new vocabulary. Instead of calling it a linear equation, we're calling it a linear function. Instead of calling it an equation, we're calling it a rule. Remember, I always talk about math being a language, and there's more than one way to say a tree is tall. A tree is big. The tree is really high. The tree touches the sky, right? I mean, those are all different ways of saying the same thing. Math is no different. Okay, so we're talking, so when they say what rule, they mean the equation. You're looking for the slope, you're looking for the y-intercept. All right, I'm going to skip ahead to question 4. All right, which rules represent a linear function? In other words, which equations represent a linear function? So not all equations create graphs that are a perfectly straight line. And again, I showed you some of these in class that make all kinds of weird things happen, curves and wiggles and whatnot. So if I'm given a bunch of equations, how can I tell which ones are linear? Well, there were 3 things, right? There were 3 things that we were looking for. Number 1 is we wanted to have no absolute value signs, right? They can't have any absolute value. So we say no absolute value. And remember the symbol for absolute value is those 2 bars. And anytime you have absolute value bars, you're going to get a graph that makes this V shape, right? You're going to get a graph that makes this V shape. It's going to move around and stuff depending on the numbers. But if you have absolute value bars anywhere in your equation, you're going to get a V shape. The second thing we were looking for is, remember the keyword here is no exponents. Exponents are what make graphs curve, right? So an example here, an example would be like y is equal to 2x squared. All right. Here, there's a variable, there's an exponent on our variable. This is going to create a graph that looks something like this, right? It's going to curve. It's going to make this U shape. And you're actually going to study this a lot next year in algebra. But anytime you have an exponent on a variable, you're going to get all these kind of crazy curves. You might get one that curves like this. You might get a graph that curves like this, right? So we want to make sure there's no exponents. And then the third thing that we were looking for is that there's no variable in the denominator. No variable in denominator. So if we have a fraction anywhere in our equation, we want to make sure there's no variable in the denominator. So an example of that would be like y is equal to 7 over x. And I think I showed you an example of this in class. You get some really weird looking stuff when you put a variable in the denominator of your fraction. All right. So as I go and I look through these rules here, notice it says select all that apply. All right, select all that apply. So there's going to be more than one answer. And the boxes also let you know. If there's going to be more than one answer, there'll be boxes. If there's only one answer, it's going to be circles. So let's look at this first equation. Y equals x over 4. So I'm looking at this one right here. Does it have absolute value bars? Excuse me. No, it doesn't. Does it have any exponents? No, it doesn't. Does it have a variable in the denominator? No, it doesn't. The x here is in the numerator. This equation right here is identical, mathematically identical to y is equal to 1/4 x. All right. So that's really what we're looking at here. So the slope is 1/4. The y-intercept is 0. Right. Now we don't need to know any of that for this. We just need to double check that, hey, it doesn't have any absolute value. It's got no exponents and it's got no variables in the denominator. So this equation is definitely linear. Okay, if we're to graph it, it's going to make a straight line. What about the second equation? Y is equal to 2 over x. All right, this one definitely has a variable in the denominator, right? The x is in the denominator. This is where you're going to get a crazy curvy graph. It is not going to be a straight line. So we're not going to check that box. And my third one is y is equal to x cubed. That has an exponent. This graph is actually, this is the graph where it's going to look like this. If I go ahead and graph it, I'm going to get a line that curves like this. So only one of these actually would be a straight line if I graphed it. So I'll check my answer. Got it. All right, so you should definitely write down this little list here. No absolute values, no exponents, no variables in the denominator. That's kind of a checklist. If we were in class, I'd have you put this in your notebook. I'd have you get your notebooks out every day. Turn to this page when we're using this. So you kind of got to do that on your own. All right, the last problem I'm going to go over is number 6. All right, so we're going to, in this unit, we're going to start looking at actually using these equations, what we're now calling function rules, more to represent things. So they just give us a little story here, and we want to write an equation that represents what's being said in the story. Ben is 4 years older than Nicole. What function rule describes Ben's age for any given age of Nicole? So I don't know, maybe Ben and Nicole are brother and sister, right? And we know that Ben is 4 years older than Nicole. He's the older brother, she's the younger sister. And so we want to write some equations so that we can figure out, hey, no matter how old Nicole is or Ben is, we can always figure out the age of the other. All right, so let's think about this. Ben is 4 years older than Nicole. So we need to translate this into math. And notice they give me 4 equations in here, and they all involve a 4 because we have this 4 right here. But let's think about this. Let's start with, well, it says Ben is, and again, math is a language. It says Ben is, look at all my equations. They all start with B equals, okay? That's how you say Ben is in math, right? We're using, they're using a lowercase b here. I would use an uppercase, but this is how you translate, right? Ben is, B equals, all right? 4 years older than Nicole. So we need to take Nicole's age, okay, whatever Nicole is, and we need 4 more than this, right? To make sure this balances, right? An equation is a scale. It's supposed to balance. Well, this n right here, Nicole, we need to add some amount to it in order for it to equal Ben's age, right? Well, Ben is 4 years older, so I have to add 4 to Nicole's age. So for example, if Nicole is 10, well then 10 plus 4 is 14, right? Ben is 14. If Nicole is 50, then I add 4 to it. Ben is 54. So I go and I look at my equations here, and I see this one down here. I wrote n plus 4. They wrote 4 plus n. When you add two things together, it doesn't matter what order you write them, right? 2 plus 3, that equals 5. I could switch the order here. I could write 3 plus 2. That also equals 5. So it doesn't matter what order I write this in. So this equation right here, for me, equation D, this will tell me, you could give me Ben's age and I could find Nicole's. You could give me Nicole's age and I could find Ben's at any point in their lives. Check answer. Got it. Okay, so I know I went over a lot of stuff in class. This video is just to give you a help on a couple of problems. Again, it's not meant to... It's important for you to ask questions, right? I can't answer every question that you have in a 15-minute or less video. All right? So please, please, please make sure you ask lots of questions so that I can help you out. All right. See you in class.